Good afternoon, everyone, and thank you for taking the time to join us in this session. I'm Sharon Jin, a Senior Lead Consultant with ArcGIS Singapore. And today, we're going to take some time to talk about some of the advancements in ArcGIS technology that will change the way you deploy, operate, and collaborate. I'm going to start with the first on my list, which is ArcGIS Enterprise on Kubernetes. It is a new cloud-native deployment for your enterprise GIS, designed for scalability, resilience, and maintainability. And as you can expect, it can also be fully automated. It is the third deployment option that is available for those who are adopting a containerized architecture for the deployment of their apps. It is compatible with both AWS and Azure, as well as the open source Red Hat OpenShift. It is best suited for organizations with large systems experiencing high amounts of requests and thus requiring a highly scalable and resource-efficient deployment option. There are three aspects of this deployment option. The first one being how the software is being delivered, as opposed to traditional deployments where a setup file is used to run the installation. ArcGIS Enterprise on Kubernetes is packaged as Docker containers and made available on a Docker registry. A deployment script is provided to allow access to the Docker registry and run the installation. The next is the orchestration engine on which ArcGIS Enterprise is run on. And this relies on Kubernetes, which is designed for cloud-native deployments. It works like a distributed operating system, making it easy to deploy, manage, monitor, and scale. Lastly, the large part of the efforts was put into breaking down each component of ArcGIS Enterprise into small units of functionality. Each piece of these microservices is distributed across multiple worker nodes, providing resilience and scaled individually, allowing system resources to be assigned to exactly where it is required. In a nutshell, ArcGIS Enterprise on Kubernetes simplifies the way you deploy and upgrade the software, and also provides demand-based resource allocation and efficiency in resource usage. What it is not is that we have not intended it to be a replacement of traditional deployments. ArcGIS Enterprise on Windows and Linux as a deployment option are here to stay. The next big thing that I would like to touch on focuses on improving communications and collaboration between user groups performing very different tasks within the built environment. Introducing ArcGIS GeoBeam as an intuitive and innovative way for project teams to share and access latest versions of project data stored in multiple systems on a single application. Configurable web apps enable various stakeholders to format information, providing efficiencies in exploring and visualizing data. What you see here on this slide is what we have currently in terms of GIS and BIM integration. An ability to integrate data published on ArcGIS Online and Enterprise into InfraWorks and Civil 3D, and also to access your BIM and CAD files that are stored on the Autodesk Construction Cloud from within your ArcGIS Pro. With the release of ArcGIS GeoBeam, it will feature tighter integration between the Autodesk Construction Cloud and ArcGIS Online and Enterprise. That will enable the creation of a GeoBeam project and GeoBeam applications. Linkages between features in the GIS and files stored in Autodesk Construction Cloud can be made, and both sets of data can be visualized on a single application, supporting integrated visualization and querying. To illustrate this video shows on the left what you will see in the GIS. There is your base map, your infrastructure layers, and building scene layers. And what is selected in the GIS is the AC unit on the rooftop. And on the right is the Autodesk Revit model of the selected AC unit. And there you are able to examine the full route of the ductwork and engineering specifications that are linked to this AC unit. The same can be done with Autodesk Civil 3D models and AutoCAD files. When a rail feature here is selected, I can open up the link and see the latest work in progress infrastructure drawing that is shared by contractors on the Autodesk Construction Cloud. This ability to bring GIS and BIM together in this manner helps to improve coordination across the full project team. Next up on the list is ArcGIS Field Maps. ArcGIS Field Maps is a new mobile app that brings together map viewing, data collection, asset inspection, and location tracking workflows into one integrated application. A typical field operations workflow revolves around these 6 steps. Field work needs to be coordinated and planned. Field workers need to navigate to the site and to be able to understand the surroundings to locate the asset and capture information about it. Monitoring of your worker locations are also key in assessing the progress of the job and for the coordination of unplanned works. Traditionally, each of these steps is managed by a different app, requiring your field workers to launch multiple apps just to complete one job. With ArcGIS Field Maps, we are incorporating all of these functions of the field operations workflow into a single app, building additional efficiencies and convenience into the field worker task. ArcGIS Field Maps also features several key enhancements on top of what is currently available on Collector. One of the first is support for working indoors. When a map contains a facilities and levels layers which are compliant with the indoors information model, it will unlock floor awareness capabilities. A floor picker tool will appear for the facility in the center of the map view, and it will show the floors available for that facility. Tapping on the particular floor will filter the map view to only show features present on the selected floor. Another key feature of field maps is one that must have been the most requested, and that is smart forms. The first release of these new form capabilities will include the ability to use groups to organize the fields. This is especially useful if your data collection form has many fields. You'll be able to organize all of these fields into logical groups, provide the group a name and a description, and be able to collapse and expand them. Using arcade expressions, fields will be able to have conditional visibility, where you can apply the visibility of the field based on the condition being met. You can also define a condition with which a field is required. And voice recognition is also supported as a form of input into the fields, providing greater convenience, especially for long inputs. There will also be more functionality built into smart forms in subsequent releases, and it will also make its way into other apps like ArcGIS Viewer, web editing apps, and eventually ArcGIS Pro. Another exciting new feature of field maps is the ability to support utility networks. It is currently in beta stage with the ability to support network tracing through trace configurations and also support the viewing of various associations like connectivity, containment, and structural attachments. This opens up endless possibilities for your utility field workflows, where access to precise connectivity information and network tracing can help field engineers correctly identify live circuits and assess the impact of a network outage while out in the field. Fourth on the list is ArcGIS Velocity, Esri's new offering for real-time data ingestion and analysis on the cloud. ArcGIS Velocity, like its on-premise cousin, GeoEvent Server, allows you to connect to various data formats and protocols for data ingestion and be able to analyze the incoming data in real time, and even perform big data analysis in near real time and at a specified schedule. In this way, giving the possibility of not just visualizing real-time data, but also to alert based on conditions analyzed in real time. And all of these capabilities are delivered as a software as a service. The feed of input data can come directly from smart sensors or through IoT platforms or even published APIs. ArcGIS Velocity comes packaged with input connectors to commonly used IoT platforms and supports APIs through HTTP connectors. The data feeds ingested through ArcGIS Velocity are stored for both real-time and big data analytics, as well as visualization through configurable apps. Velocity also includes a range of real-time analytic tools that can be combined in the flexible model builder to perform the analysis step by step. The results of the analytics either get stored into a feature layer for visualization or be used to notify stakeholders of specific alerts or incidents, and even to send commands and triggers to external systems to actuate behavior. In addition to real-time analytics, big data analytics is also available for you to analyze the large amounts of data that is coming in from the feeds. They can come in the form of fully configurable analysis tools that are used to process information for patterns and trends. And they can be configured to run in near real time or at a specified schedule. You will see on this slide, which summarizes the input data sources that is supported by Velocity, the different data formats that the feeds can come in, as well as the outputs that Velocity can write into. You will see that we support common IoT platforms like Azure Event Hub, AWS IoT, and Kafka, as well as message brokers like MQTT and RabbitMQ, and data sources like GeoTab. And together with the rich set of analytic tools available out of the box in Velocity, you are able to very quickly and easily connect and configure your real-time workflows and analysis without any customization required. Last on our list today is another new product offering on our cloud platform. ArcGIS Image for ArcGIS Online opens up image hosting, management, and analysis capabilities on the cloud, simplifying imagery workflows that traditionally required an ArcGIS enterprise setup. Its capabilities include hosting of tiled imagery for fast streaming, dynamic imagery for on-the-fly processing, as well as advanced processing and analysis of imagery. Raster analytics available in ArcGIS Image comprises of 27 ready-to-use tools, including deep learning tools like object detection and classification. There are also more than 160 analytic functions available for use in the raster function editor for image processing and analysis workflows. And they will work for both tiled and dynamic imagery layers. These sophisticated raster analytics and deep learning models generate insights and data that can be shared along with the hosted imagery and image services. And all of this is now made available in a fast-free deployment model on the cloud. And with that, we have come to the end of our product highlights. And we would like to thank you for staying with us through this session. If you're interested to have more details about what we have shared today, please feel free to scan the QR code to connect with us. Thank you.